Hi everybody, my name is Amir Sharif and I'm a PhD student at Fondazione Bruno Kessler, Trento, Italy. It's a pleasure to share my experience with you all on security issues in OAuth and OIDC-based implementations. In this talk, firstly I will introduce the two de facto standards for access delegation and authentication, which are OAuth 2 and OpenID Connect standards. After that, I will explain the implementation challenges that developer will be faced in order to integrate these solutions within their apps. And then we will come into the most interesting part from my perspective, which are the OAuth security best practices follow up with essential parts for native apps. In experimental analysis part, I will share with you some of our findings when we analyze top-ranked Google Play Store applications which are integrate either OAuth or OpenID Connect solutions. And then I will conclude this talk in the conclusion section. So let's start with the basic concepts. OAuth is a protocol specifically designed to obtain access to APIs without sharing your credential with third-party apps. And it allows different access granularity, which means that you can grant access to specific resources plus revoking this access at any time. A good example is the hotel key card. What you will do when you reserve a room in a hotel, when you arrive, you will go to the front desk, then you will prove your identity, and at the end they will give you a key card that will enable you in order to access your room in the hotel. So I think it's obvious that the door doesn't need to know who you are to open the door. It only needs to verify that the card is allowed to open the door. In the software world, I think all of you will be familiar with different applications and scenarios that are used this in the world. So consider the Evernote app that you want to integrate or add all of your Google Drive files within this application. So what you have to do is to sign with the Google and then allow the Evernote app in order to access your files on the Google Drive on behalf of you. So you will prove your identity into the Google, and then it will ask you if you want to enable this application to access your file on behalf of you. And if you allow this, the Google will issue an access token that enables the app to access the Google APIs in order to integrate your Google Drive file within the app on behalf of you. The most important point is that, as I mentioned earlier, OAuth is designed to obtain access to APIs, so it is not an authentication standard. And if you use it for authentication, a lot of things can go bad. So that's why the OAuth working group introduced the OpenID Connect standard, which is simply an identity layer on top of OAuth in order to provide single sign-on mechanism. And it introduces ID token and user info endpoint in order to obtain the user identity information. So simply, whenever you want to do authentication, use OpenID Connect, and if you want to access an API, simply use OAuth. So now, let's see what are the implementation challenges that developers will be faced in order to integrate their solutions. So let's start with the OAuth port and see its complexity. So at first, OAuth port was very simple. It was a core draft RFC 6749, the OAuth 2 authorization framework, that explains how to obtain an access token, and then another RFC 6750 that introduces or explains how to use this access token. And as a complementary material, the OAuth working group released RFC 6819 that explains the OAuth 2 threat model and the security considerations. And then a lot of more OAuth RFCs has been published that introduce new mechanisms for different use case scenarios, and besides, it defined best current practices like RFC 8252 also for native apps that explains how OAuth should be used for native scenario. And I admit that it's somehow complex for developers, and probably this slide make it more clear. So consider this developer wants to integrate an OAuth solution within his application. First of all, he has to refer to OAuth OIDC solution provider website to read their documentation. And beside that, he had to read and understand a lot of RFCs that can be a tough work for non-security experts. Another problem that is in the world is that this complexity leads to a lot of implementation flows. And I think everyone's still seeing this many kind of implementation flows and non-anti-patterns that are used in the world. Here, I just mentioned some of them, like usage of implicit flow, storing the API case in plain text, which is very common in context of native apps, and then improper validation of the state parameter that could lead to CSRF attacks, and a lot of more. And that's why these kind of anti-patterns lead to different vulnerabilities. And the newest one is the internet bank account takeover of more than 1 million users due to wrong implementation of OAuth in the bank application. And I think that's why the OAuth working group starts to provide security guidelines to assist developers with secure implementation of OAuth and OIDC-based solutions. So let's take a look to this document. So the latest draft is published in October of 2020, and it's an extension on the previous security best practices, which is RFC 6819, and it updates and extends the security threat model in that document in order to cover the new threats that are due to the broader application of OAuth in the world. And it provides more specific recommendation and easier to implement mitigations. In the upcoming slides, I go through some of them that from my point of view are the most important ones. So the first one is related to the access token leakage. So simply do not use implicit grant flow. And instead of that, you can use authorization code flow or any other response types that return the access token in the token response. But why you shouldn't use the response type token or implicit? The reason is that in case of implicit, the token returned from the authorization server inside the URI, and it exposes the URI and it exposes the access token in the URI that can lead to access token leakage from the web applications in different ways, like XSS, browser history, through refer header, and etc. Therefore, in order to avoid this access token leakage, just simply upgrade your flow from implicit to authorization code flow. The second one, which is one of the most important things, is to use PXE for all client types in order to mitigate the code injection attack. So let's see what is this attack and how PXE can avoid this attack. So consider that the authorization code leaks to the attacker somehow through, let's say, refer header. So what an attacker do in his session is that to start simply the regular OAuth flow, and then after he performed the authentication authorization, and actually he can escape this part as well. So he can modify the authorization response as he's having his own device, so he can easily intercept the response and then substitute the code issued for his session with the one he obtained here. And as the token request will contain this code together with the client identifiers that are the client ID and client secret. So the IDP checks if the code is bound is issued for that specific client, and then with client secret, it will authenticate the client application. And if all of the checks succeed, it will issue an access token. That actually this access token has no associated the attacker in his session to the legitimate client with the victim's resource or the identity. So the problem here is that this code is just bound to the client identifier. And if the attacker obtained this parameter, he can easily change it to obtain the access token. But now let's see how Pixie can avoid it. So Pixie define a code challenge, which is a hash of the code verifier, and it will send it in the authorization request. And then what is happening is that here in the token request, the client will send the code verifier, which is the which is, let's say, the parameter which is used in order to create this code challenge, and it will check that this code verifier, the hash of this code verifier received here is the same as the code challenge sent in the authorization request. And if they are not matched, it won't issue an access token. So therefore, in order to make this attack successful, the attacker needs to know the code verifier used in the first flow, that this code is bound to that. And as the attacker cannot know that, this attack cannot be proceeded anymore in case there is a Pixie there. Now, another important thing that the OAuth working group discussed in this new draft is how to prevent the mix-up attack. Mix-up attack can happen if you have multiple identity providers inside your client, and for both of them you're using the same client, the same redirection URL. So how this attack can happen? So consider that one of these IDP that are used by the client is compromised by the attacker, that we call it IDP-A or IDP adversary. So the client simply start the OAuth flow with the adversary IDP. And inside the browser, it will store that this IDP is used as an authorization server. So what an attacker will do when he receives this request, he will substitute the client ID with the client ID identifier of the client at the IDP honest, and then he can add another arbitrary code challenge, and then return. And then after he modified this, it will send this request. It will redirect the user browser to this new location, and then the user will think that he's authenticating in the first IDP while he's doing the authentication in the honest one, and as a successful authentication authorization process, a code will be issued that is related to the IDP honest. And then when the browser redirects back to the client, as the client thinks that he's speaking with the IDP adversary one, he will send the code to the IDP adversary, and then an attacker can obtain the code, and as he already knows the code verifier that are used, this code, in order to obtain the token from the honest IDP, and then he obtained an access token that is related to the resources of the benign client at the honest IDP, and he can access the user's file. So how you can avoid this attack? So the first is the usage of the each parameter. So the authorization server can return this parameter inside the authorization response in order to indicate an authorization server that issues the code. So here, by having this, simply when the browser sends the code to the client will check the each parameter, and he will notice that this issuer is different from the one that he started the authorization process with that, and simply that will be mitigated. Another important attack that is nothing because of the wrong implementation, that is nothing to do with the developer, it's mostly because of the authorization server, is called Pixie downgrade attack. So the reason is that the authorization server does not enforce the Pixie, and it allows an authorization request to proceed without having the code challenge parameter, there. So what's happening here is that, so consider that the user starts authorization process with one of the clients of the IDP, and then when he perform the authorization and authentication, the attacker can so when he performed this authorization and he's waiting for the authorization response, so the attacker can hold the user session here. So for example, you can have like a malicious browser plugin that can do this for him. So what he will do is that he will start another OAuth flow with that client. And what he will do, as he is doing it in his own device, he can omit the code challenge. And as I mentioned earlier, because the IDP allows this request to proceed with the code challenge as well, the attacker can perform the authentication, and as a result of successful authentication authorization, he will obtain the code. And what attacker do is that he will send this authorization response to the user's browser, and the browser will send the code that is actually issued to for the attacker to the client, and then the client will exchange this code with the IDP. And as this code does not point to any code challenge, there will be no PXE check, and then with this access token that belongs to the attacker's resource, so it will let's say it will connect the attacker session to the client. And so, as I mentioned, in order to avoid this kind of attack, the important thing is that the authorization server must enforce PXE. So first of all, in the authorization request, he has to check if the code challenge is there, and if it's not, it should return an error. Or in the token request, if we see the code verifier there, while there wasn't any code challenge here, he can guess that there is something wrong, and he can drop the request here as well. So the final thing that I want to discuss in this part is the PXE or PXE and non-sidestep attack. That this could be happen if the clients use PXE for some of the flows and use nonce for other flows. For example, consider that the developer use the PXE for OAuth poor flows and use nonce if he has implemented the OpenID Connect scenario. So what can be goes wrong is that consider that attacker stole a code that is bound to the nonce and then injected inside a session that is used the PXE. So what will be happening in simple word is that because this code is not bound to this code challenge, so the authorization server will ignore the code verifier. They will do, it will not do the PXE check, and it will issue simply the access token or ID token. And here, as there is the poor OAuth flow, the client will ignore the nonce and ID token, but it can use easily the access token. So please check your implementation against this kind of scenario. So if you have authorization authentication in your app, check if you use only PXE or PXE and nonce altogether in all of your client implementation. And finally, this table is summarizes the BCPs that are recommended by OAuth working group, and I categorize them for the sensitive and non-sensitive sectors. With sensitive sector, I mean the scenarios that are demanding higher level of protection and security, let's say. And with non-sensitive, I mean the scenarios that you can consider the basic configuration of OAuth and OpenID Connect for them. And sensitive, for example, could be the scenario of financial or let's say fintech scenarios or governmental scenarios, while in case of non-sensitive, you can have the basic social login, let's say. And they are almost the same, while the BCP sensitive, they are providing let's say more restrictive recommendations. For example, in case of client authentication, they recommend to use NTLS or private key jobs, while in case of the sensitive with client secret basic, you're fine. Now let's see what are the essential recommendations in the context of native apps. So the first recommendation is to use code flow with a client secret. The reason is that public clients are not capable of storing client secrets in a secure way. And what I noticed a lot in the native app scenario that the developer, they are storing the client secret in plain text, so which is not a good practice, let's say. So if you need to use the client secret during two legacy reasons, use dynamic client registration method, which is known as a good practice. So it won't solve all the problems, but still it will give you application-specific client credentials. Secondly, as we discussed in the previous part as well, please use PXE. That PXE provides a lot of benefits like mitigates code injection and reply attacks. The third one is to secure the redirection from IDP to app in order to avoid redirection hijacking. So in the context of native apps, you have two options: use the app link, and the second option is to use the internet stream. The app link, it introduces in October 2015. It works with Android 6 and higher, and it provides a way to avoid redirection hijacking by associating the redirect URI with your app. That this association is done by using the package name and the developers using the developer signature hash. And the problem with the Android app link is that only Google Chrome supports by the time the Android app links, and in other browsers like Mozilla is still there are some problems that are under investigation. So another option is use the internet scheme. So it provides wider range of support, and it open authenticate app by using the package name. The final recommendation is to use external or in-app browser tabs, which are known as custom tab as well. As the OAuth working group strongly discourage usage of WebView, as they are violating the principle of least privilege, and they can lead to user credential leakage. So in a state of a WebView in third-party application, please use custom tabs or external browser. So in this slide, I want to introduce the plugin that we developed in our group, which we call it Meet Assistant. It's by the time an Android Studio plugin based solution for native app developers. It provides a GUI supporting app developers in the selection of proper flow and options, and it automatically integrates the customized code, which extends the app to support the authorization and authentication of end users using OAuth and OpenID Connect. And as a core, it used the Apple's SDK, which enforces the best current practices set out in RFC 8252. And as you can see in the picture, so you can easily run the plugin, and then you have to provide some information, and then the plugin will will integrate the code automatically in your application. So let's dive into the experimental analysis, and let me quickly share with you some of our findings during the top-ranked Google Play Store applications analysis. So we we select the apps from different 13 categories, and we are wondering to check if their OAuth OIDC implementation are compliant with best current practices, and what are the secure implementation choices which are done by developers. So these features that we select for app, we are checking their SDK support. So if they are using official SDK or they are using unofficial or they build the flow from scratch. And then we check if they are compliant with best current practices for native apps. And in the context of implementation issues, we are checking if they are using HTTP schema or app link correctly and how they manage the secret if it is needed. So from 87 apps, in total, 6 of them are compliant, and the others have at least one BCP violation. So 38 apps out of these 87 are using official SDK, and the other 49 apps are using either unofficial or they built the flow manually. And in the official instances, in the app that are using the official SDKs, there are lots of apps that are either removing PXE or they are not implementing the PXE. And there are 12 apps that are using WebView or they are using the implicit flow. And on the other part, in the unofficial part, we have 49 apps that are using unofficial or no SDK. And only 2 of them are compliant. And other applications, they are violating the BCP either by using the embedded browser or omitting PXE when it's mandatory. So the final part. So I want to conclude my talk with these 3 takeaways. First of all, please use certified SDKs that are handling a lot of things in the flow for you, instead of building everything from scratch. And secondly, and the most important one, is to stop the usage of implicit flow as it is known to be problematic, and use PXE for all client types as it brings a lot of benefits, like it can avoid the code injection and code replay attacks. And with this, I'm going to conclude the presentation. So thanks for joining me, and it's time for feedback and questions.